Question number 6. The weight of an object on Mars varies directly as its weight E on Earth. A person who weighs 120 pounds on Earth will weigh 48 pounds on Mars. Part A of the problem is find a linear function that relates the weight on Mars to Earth. So first we have to get the variables that they give us. M is equal to E, but we have to multiply E by something so we could by a constant so that we could get the weight of the object on Mars. So we'll just label the constant M. So we get this function, so we just plug in the numbers that they gave us in the problem. So 48 pounds is equal to the constant M, and then the weight on Earth, which was 120 pounds. Then we just divide 120. So M is equal to 48 over 120, which is equal to 2/5. Alright, so part B of the problem is how much would a person who weighs 190 pounds on Earth weigh on Mars? So we just plug it into the function that we found in part A, which is M equals 2/5 times E. So you just multiply 2/5 by 190, and then the weight would be 76 pounds. So the next problem is number 8, which is the speed trap problem. And the problem is the fine for speeding ticket in the town of Speed Trap is $70 plus an amount that depends on the speed. The first 10 miles per hour above the speed limit, there's a $5 charge for every mile. For the second 10 miles per hour, there's a $10 charge per mile. For an area where the posted speed limit is 55 miles per hour, express the fine amount F as the function of a driver's speed X over the intervals 0 greater than or equal to X less than or equal to 80. So for this one, we have to make a piecewise function, which is going to be presented as F of X. We're going to have to make three equations or problems. So on the left side, we're going to put how much the ticket's going to cost. And for the first one, it's going to be 0 if you're going between 0 miles per hour or 55 miles per hour. There isn't going to be any ticket if you're going in between the speed limit. For the second one, there's going to be the $70 charge plus the $5 for every mile that you're going. And you multiply that by X, which is the speed that you're going at, minus 55, which is the speed that you're going at above 55 minus 55, which will give you how many miles you were going above the speed limit, and you multiply that by 5 and add it to 70. So this is if you're going 55 greater than or less than or equal to 65. For the third problem, you're going to add 120, which is every mile per hour that you went above from 55 to 65. So you're going to add 120 plus $10 for every mile that you're going, and it's going to be the same. You're going to be X minus 6. At this time, it's going to be 65. And then this is going to be if you're going 65 miles per hour or 70. That's it.
Alright, this is exam 3, number 7. The magnitude M of a star is a measure of its brightness B, given by the formula M is equal to negative 2.5 log B over B naught, where B naught is a constant brightness of an average star. Part A. What is the magnitude of an average star that is a star with the brightness B is equal to B naught? Well, first we take the equation that we were given, which is M is equal to negative 2.5 log B over B naught. And as you see here, if B is equal to B naught, let's just say it's going to equal to 1. The log of 1 times times 2.5. Log of 1 is equal to 0 times negative 2.5 is 0. So our magnitude is equal to 0 on the average star. Part B. As the brightness B increases, does the magnitude M increase or decrease? Explain. Is a magnitude 2 star brighter than a magnitude 1? Well, if we take what we're given, B, and it's saying when B goes up, what happens? Well, if we have log of B over B naught, and we increase the brightness, this is going to go up. So if we multiply this by 2.5 log of B over B naught, this will also go up. But since in the equation we have a negative in front of the 2.5, negative 2.5 log of B over B naught, this whole equation goes down. So for the first part, as the brightness increases, does the magnitude increase or decrease? Well, as you can see here, when the brightness increases with the negative, the magnitude decreases. And for the second part, this tells us that a magnitude 2 star would be dimmer than a magnitude 1 star because the brightness will have to go down for the magnitude to go up. Part C. The star Betelgeuse in the constellation of Orion has a magnitude of 0.75. What is the brightness in terms of B naught? Well, first we take what we are given, which is 0.75, and we equal that to our average star equation, which is negative 2.5 log B over B naught, like that. And then from here, we can start to dissect the problem. We can divide the negative 2.5 to cancel this out. And over here, that gives us negative 0.3 is equal to log B over B naught. And from here, to get rid of this, we could take the log of both sides, take the log here, take the log here, and then that'll give us 10 to the negative 0.3 is equal to B over B naught. And then to get B by itself, we'll multiply by B naught. And our final answer, we get B is equal to 10 to the negative 0.3 times B naught. Part D. When a star goes supernova, its brightness can increase by a factor of 10 to the 8th. If Betelgeuse, which currently has the magnitude of 0.75, were to go supernova, what would its new magnitude be? Well, again, we start with the original magnitude. So 0.75 is equal to negative 2.5 log B over B naught. And from here, we could start to form a new equation. We'll call it M new, the new magnitude, is equal to negative 2.5 log, but now our brightness is being multiplied by 10.8, so it's 10 to the 8th B over B naught. Now our brightness is increasing here. So now we could dissect, or we could take apart the second half, so negative 2.5 log 10 to the 8 times log B over B naught. And then we can go one step further, negative 2.5 log 10 to the 8th plus plus 2 negative 2.5 log B over B naught. And from here, if you focus right here, this is the same as our original problem right here. So we know that this part already is equal to 0.75. So if we go over here, we can see right here, negative 2.5 log 10 to the 8th plus 0.75. And if you multiply all this out and do everything, it equals to negative 20 plus 0.75, which is equal to negative 19.25. And that is M nu.
So this problem is from exam 2, number 3. So 1 serving of tomato soup contains 100 calories and 18 grams of carbohydrates. 1 slice of whole wheat bread contains 70 calories and 80 grams of carbohydrates. How many servings of tomato soup and whole bread are required to obtain 230 calories and 42 grams of carbohydrates? What you want to do first is write down your given. So you're given that in a tomato soup serving you have 100 calories and 18 grams of carbohydrates. And for 1 slice of whole wheat, you have 70 calories and 13 grams of carbohydrates. Now what you want to do is write 2 linear system of equations, one for calories and one for grams. So they could equal 230 calories and 42 grams. So you want to combine these two and these two together. So you're going to have 100x plus 70y, which will equal 230 calories. And then you're going to have 18x plus 13y, which will equal your 42 grams. Now you want to solve for both equations. What you could do is use the substitution method or the elimination method. I'm going to use the elimination method. And then, alright, this is problem number 3 from exam 2. So 1 serving of tomato soup contains 100 calories and 18 grams of carbohydrates. 1 slice of whole wheat bread contains 70 calories and 13 grams of carbohydrates. How many servings of tomato soup and whole bread are required to obtain 230 calories and 42 grams of carbohydrates? So the first thing you want to do is write your given. So for your tomatoes, you are given that tomato soup is 100 calories and 18 grams of carbohydrates. And for the whole bread is 70 calories and 13 grams of carbohydrates. Now what you want to do is write 2 linear system equations, one for calories and one for grams, that will equal 230 calories and 42 grams. So you're going to combine these two together and these two together to equal two equations. Alright, so one of the equations is going to equal 230 calories, the first one. So it's going to be 100x plus 70y equals 230. And then the next one has to equal 42 grams, so the second part of this. So it's going to be 18x plus 13y, which equals 42 grams. Now what you want to do is use the substitution method or the elimination method to solve for the equations. I'm going to use the elimination method, and then for that you're going to have to multiply both or one equation so you could eliminate one of the variables. So I'm going to multiply the top by 13 and then the bottom by negative 70. So the first one will be 1300 x plus 910 y equals nine 200 2,990. Alright, and then the second equation is gonna equal negative 12,060 x plus minus 910 y equals 2,940. Now what you want to do here is add them together. So this is gonna be eliminated, and it's gonna equal 50. And then all you have now is 0 and 10, 6, 40. So this is gonna equal 40x equals 50. Now you want to divide 40 on both sides, and then your x is gonna equal 5/4. So now that you found x, you want to plug it to the second equation to find your y. So you're gonna put, it's gonna be 18 5/4 plus 13y equals 42. So if you multiply this by 5/4, it's gonna be 22.5, and then plus 13y equals 42. You want to subtract 22.5 on both sides, so you're gonna have 13y equals 0. So this is gonna equal to 19.5, and then now you want to divide 13 on both sides. So you're gonna have y equals so is it blank?
Yeah.
Alright, whatever. So y equals 1.5. So what you're gonna need is you need 5/4 of tomato soup serving and 1.5 of wheat bread. Alright, this is number 2 from exam 2. You need to purchase a new computer printer and want to determine which of two models will be more economical. You estimate that you will need one new inkjet cartridge each month. The total monthly cost after X months of two printers, consisting of the initial cost and the cost of the new inkjet cartridge, are given by the functions. So one of the functions is CA equals 80 plus 24x, and CB is 145 plus 17x. Part A tells you to sketch the graph on the system of equation over the intervals 0 greater than or less than or equal to x, and then less than or equal to 12. So to make this not complicated, just use the intervals that are given 0 and 12 and plug them both on each equation and graph it from there. Alright then, so we plugged in 0 and 12 on the first equation, 80 plus 24x. So 80 plus 24, 0 will equal 80. So your first point will be 0, 80, and then you plug in 12, which will give you 368. So the next point will be 12 and 368. Okay. Alright, and then CB, you plug in the same thing for 0 and 12, and you're going to get 0, 162. And then your next point is going to be 12 and 349, and then when you plug it in, you will get it like this, and it will connect like through middle 8. Alright, part B asks, what does the coefficients 24 and 17 represent on the graph, and what do they represent in terms of the printer cost? On the graph, 24 and 17 represents the month's cost, they represent on the graph. They represent the gross, the monthly. They represent the gross cost every month on the graph, and then in terms of the printer cost, they represent the monthly cost of the printer. And then part C, and what does the cost at 80 and 145 represent on the graph, and what did it represent in terms of printer cost? This is they represent the, and the graph is graph they represent the initial value when x equals 0, and then in terms of the printer cost is the initial value of the printer. Alright, part D says solve the equation algebraically to find the number of months when the cost for the two printers will be equal, and then how much would you have to spend on either printer at this time. So since you have already two equations, you just want to make them equal to each other. So it's going to be 80 plus 24x equals 145 plus 17x. Now you could subtract 24 from 17 or 17 from 24. So I'm going to do 17x. So 24 minus 17x equals 7. So now you have 80 plus 7x equals 145. Now you want to subtract 80 from both sides, and you will get 7x equals 65. And divide 7 from both sides, and x is going to equal to 9.28 if you round. Now the second part says how much will you have to spend on either printer at this time. Then you just plug in this to one equation. So I'm gonna plug it into this one. So 145 plus 17 times 9.28. So 145 plus 157.76, and you add it together, it will equal 302. So you will spend 302.76 for one of the printers.
So I'm doing exam 2, problem 1, and it says solve each of the following systems equations algebraically, describe the graph of the system. So x equals 3y plus 1, 6y minus 2, x equals 5. Since x is already given right here, x is 3y plus 1, we could just plug that into this equation right here. So it would be 6y minus 2, plug in 3y plus 1 is equal to 5. Then we distribute the negative 1, so you're left with 6y minus 6y minus 2 is equal to 5. 6y and minus 6y cancel out, so you're left with negative 2 and 5. Because negative 2 does not equal 5, this is not a solution, so this equation does not have a solution to it. So if you follow the system equations, it will not have any solution. For part B, 2x plus y equals 2, x minus y equals 7. You need to cancel out one of the x's and the y's. So positive y and negative y, these automatically cancel out, so you don't have to do anything. So you just add this equation into this equation. So 2x plus x, you have 3x is equal to 9. You need to get the x out by itself, so you divide by 3 on both sides, and you're left with x is equal to 3. Now that you have x, you're trying to find y. So let's plug it into this equation here. So 3 minus y is equal to 7. You subtract 3 here to get y by itself. So you're left with negative y is equal to because the negative y, you have to turn that positive. So y is equal to -4. So your points here, if you follow the system equations, it would eventually, it will go through 3 and -4. And these are the solutions to exam 2, problem 1. This is exam 2, question 7, the Mount Everest. Mount Everest is estimated to have a volume of 724,700,000,000 cubic meters. A developer has bought Mount Everest and plans to grind it up and use it for the Grand Canyon, where his new Mall of the World is to build. The volume of the dump truck is approximately 64 cubic meters. How many dump trucks would it take to haul the mountain entire volume? Write your answer using scientific notation. So what you can get from the first problem is that Mount Everest is estimated to have 724 billion cubic meters. So knowing that, it's asking you to how many times would it for one dump truck to go for multiple dump trucks. So if one dump truck is 64 cubic meters, so what you have to do is get the cubic meters of Mount Everest, which is 724,700,000,000, and you divide that by the dump truck, which is 64 cubic meters. And because it's asking in scientific notation, so we're going to turn this into a scientific notation. And that would be 7.24 times 10 to the power of 11. And we can turn this into scientific notation too, which is 6.4 times 10 to the power of 1. And because scientific notation, we're subtracting it, so you're left with 1.13 times 10 to the power of 10. And this is in trucks, so you need approximately 1.13 times 10 to the power of 10 trucks to haul all this Mount Everest, and this is part A. So part B of the problem is asking if one dump truck is 38 feet long, how long of a convoy of dump trucks would there be needed to haul away the mountain of dirt? Right, in feet and then in miles, so the conversion of 1 mile is 5,280 feet. So we start with the answer we got from the previous problem before, which was 1.3 times 10 to the power of 10, and we multiply it by 38 feet long, because this is one dump truck. And for this, we get 4.294 to the power of 11. And then because it's asking it to convert it into miles, and this is currently into feet, we divide it by 5280. So we divide this, what we just got, by 5280. And our answer in miles is going to be 81,325,757.58 miles. And that's the answer for part B.
Okay.
So part C of the problem is asking, distance from Mount Everest to the Grand Canyon is 12,000 miles. How many days would it take a dump truck to traveling 60 miles non-stop? So it gives us 12,000 miles, and it's 60 miles an hour. So it's 12,000 miles over 60 miles an hour, and we have to convert it. So 1 hour, an hour, that's 24 in a day. So then we have to multiply 60 times 24 in order to get the miles per day. So that's 1444 or 1440. 1440. And since we have 1440 now, we divide 12,000 by 1440, and this is 8.3 3 days. So it would take approximately 8.33 days for the dump truck to reach the Grand Canyon from Mount Everest.